Welcome to the Angular Masterclass series, a complete guide covering Angular 20+, observables, operators, subjects, state management, and signals integration. This course offers 21 deep dive sections and over some interview Q&A. This is our course agenda, featuring 21 sections covering everything from the introduction to RxJS, observables, subjects, and various operators like map, switch, merge, concat, debounce, filter, and error handling. We'll also dive into multicasting, state management with behavior subject, memory leak prevention, reactive architecture design, and integrating RxJS with Angular signals, culminating in production best practices and interview Q&A. We begin with Section 1, Introduction to RxJS. This covers reactive programming, the push versus pull model, observable architecture, and why Angular applications benefit from RxJS. RxJS. It's reactive extensions for JavaScript, offering a unified async API for streams. RxJS is built on observable streams, which are essentially arrays in time. It provides over 100 pure operators to transform these streams. Reactive programming allows us to react to data changes using a push-based architecture, where asynchronous and synchronous operations are handled identically. Angular heavily integrates RxJS for HTTP client, router events, forms, and state management solutions like NGRX. Moving to Section 2, we have the Observables Deep Dive. Here, we'll examine lazy evaluation, the observable lifecycle, all creation operators, and an introduction to cold versus hot observables. Observable lifecycle consists of create, subscribe, execute, complete/error, and teardown. Observables are lazy. Execution starts only upon subscription. Execution emits values via next and terminates with complete or error. Teardown frees up resources. The marble diagram visually represents how sources are mapped and filtered over time. Remember, observables are cold, meaning each subscription gets an independent execution. Next up is Section 5, Subjects, all four types. This section compares subject, behavior subject, replay subject, and async subject, complete with enterprise patterns for each type. Subjects act as both observables and observers, multicasting to multiple subscribers. Each type has distinct characteristics. Subject has no replay. Behavior subject replays the last value and requires an initial value, often used for state. Replay subject replays the last n values, suitable for audit logs or late subscribers. Async subject emits only the last value upon completion, ideal for one-time async results. Enterprise patterns for subjects. We see examples for an auth store, cart store, notification bus, and audit log. A best practice is to always use a private subject with a behavior subject for state and expose it as a read-only observable via AS observable to prevent external next calls. Section 8 covers flattening operators, switch map, merge map, concat map, and exhaust map. This is a critical section, often considered the most important topic in RxJS. These marble diagrams illustrate how each flattening operator handles concurrent inner observables. Switch map cancels the previous inner observable. Concat map processes inner observables sequentially. Merge map runs all inner observables in parallel. Exhaust map ignores new source values while an inner observable is running. Remember, you read the diagrams left to right as time. Complete reference for the four operators. Switch map is ideal for search type aheads because it cancels previous requests. Merge map is for parallel, independent operations. Concat map handles sequential queues and ordered writes. Exhaust map is best for submit buttons to ignore double clicks. This distinction is the #1 most asked RxJS interview question. Here we see production-ready code examples. Switch map is used for search to prevent stale requests. Exhaust map is used for login to ignore quick double clicks. Merge map is for parallel loading of multiple user IDs. Concat map is used for an upload queue to ensure files upload sequentially and in order. Remember, never use switch map for mutations like post/put/delete. Use exhaust map or concat map instead. Section 11 focuses on error handling, covering production strategy with !catch error, !retry, global interceptors, and monitoring. !catch error, intercepts errors, and must return a new observable, !empty, or rethrow. !retry, allows resubscribing a number of times, often with an exponential delay function. !throw error, creates an observable that errors immediately. !empty, completes immediately without emissions, often used to gracefully swallow an error. Section 13 discusses cold versus hot observables, a critical distinction for preventing duplicate HTTP requests. Cold observables create a new producer per subscription, leading to values restarting, like in "http.get," or "of." Hot observables share a single execution, meaning all subscribers share one producer, and late subscribers miss past values, as seen with subjects or "from event." The fix for making a cold observable hot and cached is often using "share replay 1." Section 14, multicasting, dives into making a cold observable hot and cached using "share replay." This is essential for sharing data and preventing duplicate HTTP calls, ensuring one request serves all subscribers. A common bug is forgetting "ref count," true, which is vital to prevent memory leaks when all subscribers unsubscribe. 15 focuses on state management with RxJS. We'll explore the "behavior subject" store pattern, comparing it to other libraries like NGRX and NGXS, and introducing the lightweight "to signal" for component bindings. The RxJS store is lightweight and perfect for small to medium-sized apps, but requires manual boilerplate. NGRX offers dev tools and time travel, but has heavy boilerplate. NGXS reduces boilerplate, but uses class decorators. Signals are built in and auto-cleanup, but lack RxJS operators. For complex state and large teams, consider NGRX. In Section 16, we cover memory leak prevention. This addresses the #1 RxJS bug in Angular, streams that continue running after the component is destroyed. The ranked list shows the best unsubscribe patterns, led by "async pipe" and Angular 17 Plus's "to signal" for automatic cleanup. Section 19 focuses on RxJS plus signals in Angular 17 to 20 Plus. We'll see how to convert between observables and signals using "to signal," and "to observable," and explore the powerful resource, API for reactive data fetching. Use signals for simple local state, template bindings without the async pipe, and computed values. Use RxJS when you need operators like "switch map," combining multiple sources, or managing WebSockets and complex async orchestration. Use "to signal," and "to observable," together for maximum power. Section 18 outlines the reactive architecture, a 5-layer enterprise design. The layers are component, facade, store, service, and interceptor. The facade sits between the component and everything else, offering a single API for orchestration. This isolates component logic and ensures a thin, testable component layer. 12 details combination operators. Fork join is for parallel API calls that must all complete. Combine latest is best for reactive derived state, emitting whenever any source changes. Zip pairs emissions strictly by index. With latest from samples the latest value from another observable upon source emission. Finally, Section 21 covers production best practices, including naming conventions, encapsulation with "as observable," using "finalize," for loading states on error and complete, and utilizing "share replay" for caching. Mastering these 3 concepts prevents most production bugs.